Okay, so hopefully this little video here will help you with your inverses. I'm going to start by showing you the sine, cosine, and the tangent graphs, which we've already done. We're already very familiar with those, hopefully. So the sine graph here, we see that it starts at 0. We know its basic characteristics. But as far as taking an inverse of a function goes, back in one of the earlier on chapters, we learned that you can only take an inverse if the function is 1-to-1, meaning it's going to pass the vertical line test, or the horizontal line test, rather. This graph will not pass horizontal line test because if you put a horizontal line through it, it's going to hit in multiple places. But what we can do is we could look only at the interval from here to here. Within that interval, this function shows its full spectrum of values. It shows us everything from 1 to -1, everything in between. So basically, since this is negative pi over 2 and this is positive pi, I'm sorry, I wrote that in the wrong spot there. There we go. And this is positive pi over 2. And if I'm going to take the inverse of a sine function, I'm going to do so within this interval. So as far as the method that I showed you in class, as far as drawing the triangles go, when you're drawing the triangles for an inverse sine, you're going to draw something between positive pi over 2 and negative pi over 2, which is going to be either a triangle drawn here or somewhere down here. Whereas when we look at the cosine, same situation here. It will not pass the horizontal line test. However, if we look at the function only from 0 to pi, this covers its full spectrum of values. Everything from 1 down to -1. Every value for cosine is covered in there. So if we're going to do an inverse of cosine, we have to look within this range. So if we're drawing our triangles for an inverse cosine, it's going to be somewhere between 0 and pi. So we're going to draw our triangles either here or here. And when we look at tangents, we see the same dilemma. The horizontal line test will not, this will not pass the horizontal line test. However, if we look at just one of these sections of the graph, namely from negative pi over 2 to positive pi over 2, so if we're doing the inverse tangent, just like before, here's my pi over 2, and if I go down this way, there's negative pi over 2, just like sine. Okay, so my triangles for this are either going to be drawn up here, or they're going to be drawn down here. So we'll take a look at a few examples here. Find my mouse. So let's consider, let's say we're going to try and do the sine inverse of positive 1/2. Now remembering what I said about sine inverses, they have to occur between negative pi over 2 and positive pi over 2. Well, these are both positive numbers, 1 and 2, so when I draw the picture for this, I'm going to draw something up in quadrant 1. Something like that. So this is the angle. So we're going to say, well, if it has a sine of 1/2, it'll look like that. We should be aware that that third side would have to be a square root of 3. So if we think about this, what makes that happen? Well, it might not look like it, but when we draw the standard 30, 60, 90 triangle, we have 1, 2, square root of 3. So we're going to be able to figure out that this angle up on top here is our 60, and this thing down here is going to be 30. So the sine inverse of 1/2 is going to be 30 degrees, or if you're doing it in radians, that's going to be pi over 6 radians. We can check that. Let me open up my calculator here, and we'll do this in degree mode. So let me make sure I'm in degrees. Okay, so we are going to do the sine inverse, so second sine, of 1/2. We should get 30 degrees. And we do. Okay, let's take a look at another one here. Suppose that instead of 1/2, we had been given the sine inverse of -1/2. Well, now since it involves negative, and we look at what I told you here, where the triangles have to be drawn for an inverse sine, this triangle has to be drawn in the fourth quadrant, like this. So if I do sine of the reference angle right here, and I get -1/2, well, that means that has to be -1. Remember, we always leave the hypotenuse positive. So 1, 2, this would be my square root of 3 this time. And then I look and say, well, what angles would make that possible? Referencing the 30, 60, 90 triangle up here, we can figure out again that this has to be 60, this has to be 30. So this is a negative 30 degree angle. So negative 30 degrees, or if we're doing it in radians, negative pi over 6. So let's demonstrate that real quick. We'll do a second sine inverse of -1/2. I get -30. So similarly, the same thing would work with cosine and tangent. Let's do the cosine inverse of the square root of 2 over 2. Now the way I do these, because I'm very familiar with the process of rationalizing, I'm fully aware that this is the same thing as 1 divided by the square root of 2. That's going to help you out tremendously if you're able to do that. So when we're going to draw this reference triangle here for this problem, again, let's go back and let's look at cosine, reminding you that cosine is invertible from 0 to pi. So here we're going to be either in quadrant 1 or quadrant 2. Well, it involves positives only, so I'm going to have it in quadrant 1. Now the triangle that involves the 1 and the square root of 2 is our 45, 45, 90. Here's 45, 45. I got 1, 1, square root of 2. So I know that this has to be a 45, 45, 90 triangle. So here's my 45, 45, 1, 1, square root of 2. Sure enough, here, the cosine of this angle would be this 1, right down here, divided by the square root of 2. So I know that this has to be 45 degrees or pi over 4 radians. Let's demonstrate that here. Second cosine of, let's type in the original way. We had the square root of 2, close that, divided by 2, 45 degrees. I think we'll do maybe one more of these. I had one more here picked out. Let's do a tangent maybe. I'm going to do a couple tangents with you. So let's look at the tangent inverse of, let's do -1. So now looking at the tangent graph, tangent is invertible from negative pi over 2 to positive pi over 2. So we're going to draw the triangle in either the first or the fourth quadrants. So when I do that for this, it involves negative, so I know it's got to be down here. And so I say, well, opposite over adjacent involving 1s, well, that means it has to be a 45, 45, 90 triangle. So if the tangent, the opposite over the adjacent, is -1, I know that this has to be negative 45 degrees or negative pi over 4 radian. We'll demonstrate that's true here. Tangent inverse of -1, and we get -45. One more tangent problem, though. Let's do the tangent inverse of negative √3 over 3. Hopefully you're looking at that thinking, gee, that looks like something that was rationalized, which it is. So this is the same thing as tangent inverse of, what is it? negative 1 over square root of 3. If you rationalize that, you get negative root 3 over 3. So since the tangent, once again, is invertible from pi over 2 to negative pi over 2, and this involves negatives, I know I'm down here in the quadrant number 4. So a tangent to be negative 1 over the square root of 3, it has to look like this, and then that would make this the 2. So we recognize this as the 30, 60, 90 triangle. The one, let's see, the 60-degree angle would be down here, and the 30-degree angle would be there. So the answer to this guy has to be negative 30 degrees or negative pi over 6 radians. And we'll demonstrate that that is true. So tangent inverse of, let's type it in the way it originally looked, negative square root of 3 divided by 3. And we get negative 30, just like we said. Whoops, didn't mean for that to happen, sorry. One in a circle, there we go. So that should help you as you're doing the problem set, which I did email out to you. In case you don't check that email, I will write that assignment down here for you. On page 316, numbers 1 through 7, 13 through 18, 31 through 38, and 91 through 94. Now I believe the ones in here that we definitely need a calculator to do are problems, where are they? 13 through 18? Yes. 13 through 18, you must use a calculator for those. Everything else technically could be done without a calculator. Good luck.